change anything and make it better. Together now we're strong, don't question it. The truth will break your chains, we have the key. Open your eyes and see. We are the ones who know the answers, and they ain't never gonna hold us back. The sea is rising like we dancers. Imagine life without a purpose. Now picture everything you're fighting for. Now picture everything you're fighting for. Everything you're fighting for.
What if I go stronger? What if I get higher? What if I start doing things I know I will regret? I will make my own way, I will not surrender. I will do my best until I get put under. What if I go stronger? 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 What if I go stronger?
Standing on the edge of a cliff, realize there must be more to life than this. Reaching for the stars, traveling so far, like a dragonfly. Just grab my hand from hidden sin. We need tonight.
So now Now can you tell me when you want to be in time? There's a million different places and a million different heights. I'll climb the tallest of the mountains, the highest place I find, so that I can look over and before me what is mine. Can you say that I disappeared? Can you say that I wasn't there for you when you went into hiding on the front steps of your porch? Then I reflected on the memories, but I put out that torch. Hey! But I put out that torch. But I put out that torch. Oh, why can't you see it was all because of me? And all I want is to be free, and finally I can be free. Can you say that I disappeared? Can you say that I wasn't there for you? Can you say that? That's what I'm looking for. That's what I'm looking for. That's what I'm looking for. That's what I'm looking for.
These roads intersect, on each one I reflect. These lines write my story. These places change me, each one replacing, like night into morning. I miss the open air, the going anywhere, riding with you like we used to. Guess I'm better off alone, never know when I'll get home, but I know that home's where the heart is. Guess I'm better off this way, moving to better days, but I know that home's where the heart is.
just can't let this go. Every last chance I had is gone, but I just can't let you know. I just can't let you know. But I just can't let you know.
Hi everyone. It's good to see you. So, shall we get started?
I'll just give a couple of minutes. So eating.
No, I think we will nobody eats anything, so everybody's ready to answer. So, it's good to see you all here. Welcome to 56th, if I remember correctly, DevClub event today at Taxify, who kindly agreed to host this one. And for today's agenda, we have a welcome note from Taxify for a couple of minutes. Ryan will welcome you all guys. And then Sergei Müttü takes over, a backend engineer from Taxify, and his talk will be about dynamic pricing. And then that is followed by Pipedrive's Renno Reinurm, who's talking about DevOps practices they practice at Pipedrive. That's it for today. And a small announcement from our friends. A Selenium Camp conference in Kyiv, Ukraine, that takes place on March 2nd to 3rd. So, if you're in automation business, then you might be interested in having 50% off discount with using our DevClub's promo code. Check out seleniumcamp.com. Enough of advertisement. So we also gathered some insights about you guys who come here today. And as we are hosted in Taxify today, so we ask you like if you use Taxify. Well, most of you do. Some people even use it like every day. Not much, but well, still. And a lot of people use it often, and a lot of people also the most people use it seldom, but that's normal. I myself use Taxify too, rather seldom, because I think most of us drive cars on their own. And regarding who's working on what at work, almost everybody, like almost 90 people out of 106 tickets we issued, does any sort of programming. Some of them in combination with other disciplines, say operations and business, are equally around like slightly below 40. So well, that's it from my side. Let's crack on with our first guest. Please welcome Ryan from Taxify to the stage.
Okay, so thank you here for gathering here. We at Taxify are really happy to host this event. And I'm glad to see that most of you have used Taxify. And I wanted to tell about like 3 things which are a bit different from other companies, other software companies that we have. So one thing is that we have really started as mobile first. So we didn't have any other interface for clients, but it was really mobile. So everything what we did had to be on mobile, and this is the interface for clients and also for our traders. So our customer base is basically clients and traders. We have additional websites which we support, but main interaction is through mobile. The next thing what is different is that we have really real-time systems. So every second there are people matched with their drivers. So we have to keep everything running and running fast. Any delay would cause issues for all of our customers. And this makes many things much harder to solve for us. And third thing is that if you I don't know how many have been learning computer science, but everything what you learned in school, at least I was thinking like, okay, where can I apply all this knowledge? And in many cases, there are just not enough hard challenges where you can use this know-how. But here you can pretty much assign it to every problem that you are solving, because it's really data science heavy. We need to do like really complex algorithms so that we can build the most optimal marketplace for everyone. And it's everything becomes about efficiency, how to build most efficient marketplace for everyone. And yeah, this means that we are really data science and algorithms heavy. And today, so Sergei will speak about dynamic pricing. So I'm sure you have seen this, that sometimes prices go higher. And now you get to know a bit about the details, how this algorithm works and what's behind that. And also we have Andra talking a bit about data science and data science tools, machine learning, how we apply it to solve our problems. And just a reminder that we have also Anna here, please wave. So if you want to have a tour in the office afterwards, you get to know something, please go to her after the meeting. So thanks, and now on to Sergei.
Hello, I'm Sergei Müttü. I'm backend developer in Taxify, and today I'm going to be talking about dynamic pricing. So initial plan was that it was just me talking, but at the last moment we decided that Arne Andre, our data science team lead, will join, and he's gonna talk about data science a bit, like details. I will start talking, and questions and discuss. If you have any questions, please hold them. We will have them at the end of the talk. All right. So aim of current presentation is to give you some insight how we're actually working in Taxify, what we actually do and how we do here. So dynamic pricing is just one of the problems we're actually trying to solve, and why we actually selected it for current presentation, because it's like hard and interesting at the same time. Hope kind of you like it. What is dynamic pricing and why it's actually used? A bit of theory. One of the basic law of economics, supply-demand law, states that any product, the price of any product determined by balance between production, basically supply, and desires of people who are actually willing to buy by demand. And at this particular diagram, for example, we have like quantity below and price here. Demand curve is increasing, demand is increasing, and to actually balance the system, price has to also go higher according to the supply curve. So this is like theory. In reality, the price adjustment doesn't happen automatically. So many companies, like many industries, trying to achieve that, introducing some sort of price automation, like airline companies doing that for ticket prices, hotels do that, internet shops like Amazon is the like first example which comes to mind. And of course, ride-sharing companies as Uber, Lyft, and Taxify are also trying to do that. So here in Taxify, what dynamic pricing means for us exactly. So dynamic pricing for us is the black box, a system which takes some parameters in. Riders, drivers, traffic, maybe weather, something else. Like some city particular properties and so on. And as a result, produces the price. And it does it like, oops, sorry. And it does it in real time, very fast, and for many geographical locations. So in particular cities, there can be like hundreds or millions, from 100 to millions different geographical locations where we're actually calculating dynamic price. And this is just a part of the task. It would be actually nice not just calculate price in real time. It's also nice to predict it in future. So like what price is going to be like next day, next week, maybe even further. Challenges. What are the challenges implementing, solving the dynamic pricing? There are actually two parts. One is kind of technical, scalability, another one algorithmic. Technical. Why technical? Why it's complex. So taking the previous definition from previous slide that dynamic pricing has to be calculated in particular geographical location in real time. Let's take, I don't know, some city example. Here on the screenshot I have heat map of Paris. This is some day situation there. And Paris area is around 100 square kilometers. And if we split this area into like small boxes, let's say like 100 by 100 meters, you will get like million boxes. And if you calculate price for each of these boxes in real time, then task becomes like really complicated. And if we presume that we are actually operating in multiple cities, like tens of cities, and some cities are like much larger than Paris, for example. So I don't know, it was like actually surprise for me that according to Wikipedia, Paris area is less than Tallinn. So Tallinn is 150 kilometers square. But there can be like even bigger cities. For example, in Africa, We operate in Johannesburg, which is like 16 times largest area-wise than Paris, for example. So calculating the dynamic prices in all these cities in parallel, in real time, becomes like computationally expensive task. Algorithmic part. The difficulty there is having all these parameters like drivers, riders, traffic, situation in different locations, how to actually figure out price based on that. How to find that optimal price which is good for drivers and for riders at the same time. So this is the task of kind of algorithmic part. And of course prediction of the price is also important. I will continue with kind of technical part, but before talking about like technical aspects of dynamic pricing, I will briefly run through Taxify backend, how we work, how we operate. So basically, dynamic pricing is mostly operating in backend. Of course, some information produced by dynamic pricing is exposed to mobile application and so on, some visualization, but main functionality is in backend. And Taxify backend is implemented as microservices architecture based on Node.js. We have Node.js, JavaScript, REST services. Initially, everything was JavaScript. Now we're gradually migrating to TypeScript. Everything is running in Amazon cloud. We don't have anything hosted locally. Everything is in elastic computing. We use Docker for replicating different environments, for testing, for integration test, for local testing, and so on. Databases. The main database we use, the cornerstone of Taxify, is MySQL, MariaDB. Basically, mostly all the data is stored there in a relational database.
So it is MySQL, yes?
MySQL, yeah.
And what is MariaDB?
MariaDB is engine for MySQL.
If you have any questions, then there
Yeah.
will be a question answer.
At the end, we will just have questions and discussion. For fast data, for caching, we use Redis, and for long-term storage, we use Redshift in Amazon, where we store our statistics, something which we don't write that often, but read a lot. And finally, file storage is S3, Amazon S3. So most our infrastructure stays on Amazon. All right, back to dynamic pricing. So dynamic pricing can be viewed as sort of technical platform running a set of algorithms. So like kind of algorithm carriers. There can be like one algorithm running everywhere in all the city, or there can be like several of them running in parallel, theoretically. And dynamic pricing platform provides the data, collects the data from different pieces from other pieces of the system, of Taxify system, delivers to particular algorithm, then collects the data, results, and again returns it back to different parts of the system, like showing it, for example, on some rider application or driver application. Important characteristic of dynamic pricing is scalability. So as Taxify expands, as it moves to a new city, implementation of dynamic pricing should like scale along the expansion. So presuming we implemented something and it works fine, it shouldn't be that way that we kind of go to a new city and we have to implement everything from the scratch. So it should basically scale along. In worst case, we just like add more machine and it still works. And it also should handle the load. It should handle spikes, which we have like at certain days, at certain time of the day. So we don't have the even load. For example, New York Eve is like one of the critical times where we have like much more load, much more rides, much more drivers, riders participating in the system. So everything gets more load. Data storage in dynamic pricing. So when we are talking about results of dynamic pricing, the price, it's actually very transient. So if you calculate the price in the system, you should return it back to drivers, you should return back information to riders, and in 5 minutes, like in a couple of minutes, this information becomes obsolete. So it doesn't make sense to store it to hard drive, for example. So most of the data in dynamic pricing is actually running in memory. From other side, we need a lot of data stored in long-term storage to analyze it later. So kind of we're introducing new algorithm. We want to store all the data possible, like with which algorithm was working. Input data, results, and so on. So we store it in Redshift, in files, and then we analyze it. Data science team works with these files and so on and so on. Geodata, maps. So dynamic pricing is basically built around geodata. It's actually, Taxify in general is kind of built around like position, roads, but dynamic pricing is basically 90% geodata. How we store this data, how we efficiently access this data is very important. So which algorithms we are using to actually access the data is critical. Visualization. So visualization is an important part in like 2 cases. Monitoring, seeing what's happening in cities, how situation is kind of develops is very important. It should be real time so we can react very fast. And we also should provide some feedback to our customer, like some driver view showing situation in the city, showing like hotspots in the city. And the last, but I think not quite important property of dynamic pricing is being optional. If dynamic pricing crashes, if it goes down, it shouldn't pull everything around with it. So it should just like collapse inside, and other parts of the system or other part of the of Taxify still working. You're losing this dynamic pricing, everything goes to kind of basic fee, but at least it still works. Moving forward to algorithmic part. So how do you actually design the algorithm for dynamic pricing? Why is it like that difficult? So how you start doing that? So before starting implementation of dynamic pricing, from what you begin? Either you implement technical part first, or you implement algorithmic part first. So how we approach it, we first kind of invented very naive implementation of algorithm, very simple. Using drivers, using riders, it's just like divide second one by first one and you get some number. This is something like multiplier. And then moving from there, we kind of in stages improving it and improving. Currently we are at the iteration when we clearly understand that like creating algorithm manually doesn't make any sense. So we're understanding that like future is like machine learning. That machine learning algorithms actually figuring out the perfect dynamic price for us. And this is where kind of data science team comes in. Andre will talk about data science team with details. I want to emphasize I want to kind of speak about how we actually interact with the data science team. What is the complexity of process between development and data science team? How we prepare data. So the main thing data science team needs is the data. data has to be retrieved from different pieces of system. It should be prepared, kind of cleaned a bit. So part of this job kind of on developer side. So data science team says that we're missing that data. Basically, I have to implement the way to store it, to provide it to them. As long as data science team got the data, doing the magic, producing some result, some model. This model has to be integrated back into the components. How to plug it into the code, how to scale it along with the system so it doesn't slow down all other pieces. It's also important. Currently, all the data science kind of main language in data science is like Python. Along with R, I think we are using Python, and even me as a developer, like I'm not doing this data science part that much, but working with Python is also like very convenient. Preparing the data for them, evaluating the data, debugging errors helps if we are using like similar tools data science team actually does. So we are using Jupyter for Jupyter notebooks, basically running Python on web. This brings in convenience in solving like that in preparing the data. And from my side, this is it. Andre will continue and we'll talk about data science. Thank you.
Hello, I'm Andre, and I will give you a brief overview of data science, how we work with Sergei, other engineers in the company, so that you have a better sense for what it means to create models for dynamic pricing, for models at large. So just a recap for everyone. So this is a simplified process of data science and what it means. You have to first have data. So you collect the data, you have to process it into a format that your models can use. Usually it's in a different format like protobuf, you need to convert it. And then you have to clean the data from errors so that the models produce accurate and good predictions. To find the right patterns, there is an activity called exploratory data analysis where you look for relationships between variables, and then once you find valuable patterns, you create machine learning algorithms for this that you productize. And all this happens while we communicate with Sergei, engineers, business, so that we can make the right decisions. And now going a bit more into detail, so how do we work? So first about the pre-processing and cleaning of the data. So you have data sets. We have tens of terabytes of data in Redshift, S3, Elasticsearch. At peak load, we have about 860 million requests per day. Then billions of routes. All this data has good and valuable data sets, but also things that you need to clean. So here is an example of a subset of small data set where you transform the features for your models into a meaningful format. So you can see the steps in data cleaning. And for every model, every data set you work with, you have to do this. So you have to impute the missing values. Sometimes you have to do data augmentation, creating new data from the existing data. If the data is very highly dimensional, you reduce the dimensionality. Basically, remove any inconsistencies and errors in it so you can use it. One thing we do a lot at Taxify is automatic machine learning. So we try to prototype as many models and methods in parallel. to find good performing methods. And this automatic machine learning approach allows us to try out many different predictive methods. It also does automatically cross-validation for you. You can select the best metrics for a particular task. And here you see just a list of different models and ensembles performing against a very specific task. So these are trained in parallel on the infrastructure. So far, the benefit of this is that we can do very fast pilots. So we find something interesting, we can go quicker to live. And we have created more than 300 models per week using this approach. Then once you have a good approach, good method, then what you do is you write code, of course. And this is done together with engineers, because things we have to optimize for is low latency for real-time events, and also thousands of predictions for batch data. And here you can see just some examples. So we work for one model, we work with light GBM, gradient boosted trees, and its benefit compared to XGBoost, for example, which you might know, is that it has a leaf-wise growth architecture, which gives you faster convergence to a good result. And also you have to limit the overfitting with max depth of the trees. And you iterate with these models in Jupyter Notebook, as Sergei showed. And then what we do, we compare different models to each other, compare it also to the baseline we have in live. And here you can see, for example, for estimated time of arrival, 3 different models, what is the error they produce compared to the actual duration it took for the driver to get to the rider. So we look a lot at distributions, many different metrics. And once you have a good model that you deploy to live, so right now we generate JavaScript for our NPM package manager from the runtime model. So what you do, then you continuously improve these models. And this happens interactively with the engineers. Here you can see the estimated time of arrival I showed you before, how it relates to the surge multiplier that Sergei talked about. So what you can see from these distribution graphs is that the failing rides, when someone wanted to take a ride but couldn't, are different compared to the good rides where someone got the taxi, completed the ride. You can see that the distribution of the rides is much more different for the failing rides. And this information then we can put back into our algorithm development and decide which algorithm to release in which city. So this is a very quick overview of data science part, what we do at Taxify. And now it's time for questions. And also before giving the floor to you, so we are also organizing events. Next one coming up on 8th of March is a machine intelligence conference for developers, where we have invited many different people across the globe from US and Europe. So, floor back to you.
Questions?
Right now we have around 10 or even more minutes for questions, so in this sense we're really safe.
So, what tools or framework do you use for machine learning? And that's the first question. The second one is, you mentioned that you are using ML for price prediction and ETA. Any other applications?
Yes. So the machine learning is interesting in sense and data science that it can be applied in many places where you have data, and Taxify has a lot of data. So finding the best routes, time of arrival, marketing campaigns, fraud detection, outlier detection. Basically the backlog is really long. Many places where we can apply data science. Here we talked about dynamic pricing, ETA. These are the core related to this. So The tools we use are what you would expect us to use. So in Python you have scikit-learn, pandas, numpy, scipy, all the usual stack. Jupyter is used a lot. For visualization we use a lot. For decision making we use Looker. And we know that for us neural networks make sense. Right now what I talked about was just decision trees. So for this we use LightGBM. So that's the main library for live at the moment. Yeah.
What was the name?
LightGBM.
Does the model or the phone influence on the price? For example, if in some area there are lots of people with iPhone X, will you raise the price for them?
No. Not now.
Not yet. Okay.
Not yet.
Because statistics may show that you have to raise it.
Yeah, this can be like phone model is one of the factors which can be considered like while calculating the price.
There was a question.
Yeah, a user perspective question. So I use Taxify number a lot, and I was speaking once with a driver saying like, so in my radius, the cars are shown to me actually much less than the driver can see in the radius that the car could be pulled. Is it a bug or a feature within the app? Yeah, follow up. Yeah, so when you're pulling the cars, is it actually you're sorting it like more just by the radius, like actual direction the car goes, or because what the driver told me, because when he logs in the app, say like, oh, I can wait for a call, like say an hour or 2 hours, but when the user logs in, it's like he just doesn't see the cars around him.
Well,
Maybe have bad rating.
it depends on the situation in the city. There can be cases when they're like high demand or like a low demand. So like from driver perspective, it's like always low demand, right? From the rider perspective, the demand is also always too much, so you don't get any cars. So it's hard to say that. Like I think this is like working as expected. So
it's a feature then, okay.
It's feature, yeah, I guess.
So,
Do you have the instances where drivers try to game the system, automatical system, and create search prices so they will benefit from it?
This is actually one of the interesting aspects of dynamic pricing. This is actually the case. Driver trying to simulate the demand, basically opening application, rider's application, like agreeing between each other in Facebook and trying to basically search pricing. Yeah, this is definitely the case. There are also like some bots trying to scan, in some cases just trying to gather information about, for example, our dynamic pricing. In some cases trying to affect our decision as well. So this is the factor which affects us.
excuse me, there was
Just to better understand the business impact of machine learning, can you bring out maybe
some kind of, let's say, a multiplier benefit to what have you gained with machine learning instead of like using the simple algorithm which you described in the beginning of the talk? How much better is, let's say, this rejection rate because the client can't do it enough, or what's the added benefit in business terms?
So in business terms, machine learning produces incremental value. And the baselines you create, simple ones, are quite good usually. And there is, business-wise, there is diminishing returns. You add more complexity, you get less result. But for example, with decision trees, compared to the simple approach, we've been able to beat some of the baseline models quite good. And we know that the next step, like neural networks or more complexity model, will produce a smaller step. So one of the things we have to do with a small team, there are a couple of things. So on one hand, we try to automate as much as possible in machine learning to keep the team efficient. And the second piece is we look at where we can create the biggest jump in performance. So for dynamic pricing and ETA, so with ETA we found better models. So, and we know that for users ETA is really important, so it has to be accurate. So we continue investing in this. But at some point we will see that the value grows smaller, then we decide not to use it. Other example like fraud detection. You cut the fraud by a couple of percentage points, it translates into direct money. So it depends on the business case, on the use case, what metric do you use.
Thank you for the presentation. So my question is about like as I'm far from machine learning. For example, if in software there is unpredictable behavior, how to separate that software backend, not unpredictable behavior of machine learning results and otherwise?
Yeah, so for example, for dynamic pricing, so what we did, we added some constraints in defining the target. We said that the model cannot produce extreme multipliers. So you have to add some rules around the models to make sure that they operate within constraints. So that's one thing you do.
In some sense, in the end, this like data science model, it's like piece of code. So if it starts giving out some like unexpected results, you just like debug it as well.
But if result is not constantly repeated, so if you predictable behavior happens sometimes.
Well, this is like complex case. This is, I think, something similar to multi-threading. So if you have like when you have non-deterministic errors happening sometimes, it's like very similar.
So one thing we aim for is instrumentation of what we do. So if, as I mentioned, Elastic, so we get requests, we know the context in which an algorithm was executed. So storing this data is an aim for us. So we want to store the data, the context around the execution runtime, so that we can mine for the patterns in the data if necessary. A lot of the exploratory data analysis is actually about finding out about the outliers, the relationships between variables. So it relates to the debugging, to understanding the system better. And Taxify is interesting in the sense that there is a physical part of like physical city, real cars, and then there is business part. So these two together mean that we need to collect a lot of data in decision making. Yeah, lots to explore.
Yeah, I have a question. So it was quite a while ago when Taxify was presented on DevClub last time, like around 3 years ago. And then was a question, like what if ordinary person pretends to be a taxi driver and he just like reduces himself as a taxi driver and starts serving and just not really licensed stuff, like doesn't seem to be. So now we have machine. Can you predict person that he's actually not a taxi driver? And just like he's like really suspicious type, and maybe we have to exclude him from driver list?
Like a free card.
Yeah, user profiling. So you can do a lot of user profiling.
But do you do it for drivers from now? Just in order to understand that maybe they are not really good ones.
We started building our data science team in November. A lot of things we can do.
Yeah, but do you do it?
Right now, we focus on areas you saw, some other areas, not driver profiling. We work with fraud, of course.
Mm-hmm.
So fraud is an important case. People work with data a lot there, also with models. So, and this goes into this category.
There is one area is like predicting driver movements and how to drive the car. So this is something we will actually pick up. So to see how are the drivers driving around. If some drivers are driving recklessly, we can have them training on how to drive safe. So this is like just one of the examples that we can actually do.
My question was on here.
So you were talking about your ETA model. So have you done comparisons like is more accurate or less accurate than like comparing to Google Maps or Waze? Or do you have any data on that?
So I would not comment the specifics, but what you saw were the real models, the real baseline against each other, different distributions. Results look really good.
I can add one example. So with Google Maps or map-based ETA, so you look at the map and traffic, and you assume that the person drives legally, right? But we saw that actually the ETA was always less than actually possible. And analyzing those cases, we realized that they do illegal U-turns or illegal turns. And if 95% of drivers do this, it means the ETA is actually lower for this case. And machine learning picks this up. And if there is a new road or they know the shortcuts, they are really smart. So this is what machine learning picks up. And also there is this difference in behavior. So if the drivers are driving a lot, they are a bit faster than the average person. And this means that this is also something which we can take into account and have more precise ETAs. And this is a real case, and that's why it's more accurate with these models.
What's the benefit of using this dynamic pricing compared to static price? Like in normal taxis, they have static price per kilometer.
Well, it allows, first of all, I think the intent is to balance the system. So, like, when demand is growing and price is growing along with automatically, then if you take like some geolocation, a lot of people trying to get a car and there's not enough supply, dynamic pricing react, we show it on the map and drivers actually see the situation and they're trying to move there. And in that sense, we kind of restore the balance. Also, riders, if they see like high price, some of them actually like abandon their attempts and going like by bus or something like that. So in that sense, we sort of balance the system, balance the situation in the city, and at least theoretically, like kind of improving the kind of impact on the users, basically, something like that.
Thank you.
After working on this machine learning GPS, I have plans to work on self-driving cars.
So self-driving is something that's already happening. L5 cars in Singapore, trialed in US. So we have to be aware of these cars. We are not robots company. We are optimizing the city urban transportation. So we have a fleet of drivers, we have a fleet of cars, and we have to see that the mix of those works well right now, also in the future.
What are possible fraud cases you have to fight with? Who frauds, drivers or people, clients?
People are trying to be smart, like riders and drivers are both like trying to.
Can you give example of the fraud case? I cannot. I cannot imagine. Like I don't understand.
So the easiest explanation is that anywhere where you have a credit card, you have fraud, and that's you can think from there. So.
But do some drivers do GPS spoofing, for example?
Well, drivers, like one of the simple ones, drivers just like simulating the rides, basically. The two guys agree between each other and they just like log the ride, but like, trying to log the ride and get some money for us.
Yeah, but somebody got to pay for this, right? For example, if somebody simulates the ride, you charge them for real. And then, like, driver gets less commission than you charge.
We have this,
money laundering.
We have this bond.
Money was stolen credit card, maybe.
we have the bonus system as well, so this is also taken into account.
Any more questions? Yes.
A question regarding the company's culture. Like in many companies, the #1 value is customer first, and then it's team and et cetera, et cetera. But in your case, the customer is both the driver and the end customer who wants to drive, right, on the taxi. Who do you kind of give the first value? But I mean, this is an important question, right? Because I would say the end customer who drives, but what do you say about that? Like, how do you prioritize?
Ryan?
So yeah, so actual answer is equal, and we have to prioritize both. So drivers are the ones who are offering the service. If there are no drivers, we can't offer this service. So we have to equally balance this, and then we are giving them jobs. So it's important that they can rely on us, and same way our clients need to rely on us to get the ride when they need this. So it's equally important. I wouldn't say we prefer any of them. But yeah, both of them are most important thing for us. So that's for sure.
Yes, and this is the last one.
Just general question. Maybe could you underline main differences between Taxify and Uber? Few advantages.
So we offer better earnings for the drivers. Our commission is smaller. This means also a better ride price for the customer. And we, as a company, it has been able to be really efficient in use of investors' money and own money. So business-wise, it's a very sound company. That's one of the difference.
And maybe to add, so this is also one of our challenges. So if we talked about data science team, which we recently started, so we have to do with this small team much more than others have done. That's why we are using automatic machine learning and many others. So basically we have to choose as smart ways as possible to do more value. So this is a big challenge for us. We are always looking how to do this, how to build less on our own, how to use services, how to be more effective. And this is across engineering team and across business every time.
So thank you guys. It was really nice. Now we have around 20 minutes spare time. Have a drink, have a snack, and let's get back to here in, say, 8:20.
Confession that you're my obsession. You're pulsing through me. The blood is rushing and I am trusting you'll come save me. My knees are feeling weak. Your body's close to me. I want you to come rescue. My knees are feeling weak. Your body's close to me. I want you to come rescue me.
my way back to you, until you make amends with the demons you've been through. And I can't regret leaving you alone, until you find your way back home. Find your way back home. Don't let me drown. Don't let me drown. Don't let me drown. Until you find your way back home. I can't regret leaving you alone, until you find your way back home. take my hand and we'll go away to a different place, float on air, and we'll hide away. I'll be your escape. Look up and feel the shifting winds tossing us around again. Hold tight, get ready to begin, and just levitate. No control over where we go, but we don't care to know. Ignorance is bliss. Your tears are gone, and they drifted back from where they came, and they will not be missed. Look up and feel the shifting winds tossing us around again. Hold tight, get ready to begin, and just levitate.
So, everybody ready? Before we crack on with the second talk, we have one of our sponsors back with us, DEVCLUB.EE Finance, a Bitcoin marketplace, and they're so excited to be back with us. They want to have a word. Please welcome Artur, the CTO of DEVCLUB.EE Finance.
So, in short, we came to Estonia at the end of 2015, and we were sponsors here for like a few weeks and a few months to hire people. And the last year, we were successful, right? And then we said, okay, we got what we need, it's fine. And then we were in a small cocoon, like invisible, working on our stuff. And then 2017 hit, all this Bitcoin surge, right? The price going up like crazy, all crypto madness, FOMO and stuff. And now we learned a lesson and we're ready to expand. So we are looking for technical people, DevOps, system administrators, PHP backend, maybe some other languages fine too, because we're moving into microservices, product analyst. And if you want to take the challenge, we have using new technologies and it's pretty much open. What we can use in the future because it's still like broad, and here you can work with the best tools and like the best people in the best newest industry, which is finance and crypto. So come to me after that, or write to one of the emails like info@Paxful, jobs@paxful.com, or to me, Arthur, no H, A-R-T-U-R. Yeah.
I have a question. In which crypto you are paying salary?
Well, we now support only Bitcoin, right? So for now Bitcoin, but there are other options too, like Ethereum, some shit tokens if you're interested. Like if somebody's paying attention, there's Tron, Ripple, and so on. We have all these talks all the time in the office. Guys are playing, and somebody made like 10x, 50x, and different kinds of crypto. So this is really exciting, especially this year. Thank you.
But salary is still old-fashioned.
Oh yeah. Okay, there's this is also like the perks, right? Okay, we have like very competitive salary, 13 salary for everybody. Then if you're a team lead, then we have the profit sharing by the end of the year. Then also we have twice a day meals delivered to the office. We have.
So you cannot escape from the office, right?
Right, we have it at 1 and 5, right? If you want to get the second meal for free, stay till 5. The working time is pretty flexible, but it's still good to be in the office because the knowledge sharing is really important in the fast-growing startup. And then Taxify went through that too. And then we have Ivan, our head of IT. He leads the pumping iron sessions in the gym. We have a lot of sport nutrition at the office. Just yesterday, we bought for like 3K worth of protein bars, some pre-workouts, hydroisolates, testosterone boosters, everything. So, all try. Just try it to us.
You guys work on that stuff. Anyway,
I hope they have bitcoins, why should they?
Please welcome to the stage Renno Reinurm from Pipedrive with DevOps practices.
Yeah, it's so exciting that I even misspelled my name. Well, so thank you for listening me. It's gonna be very hands-on session. My slides are not so beautiful as previous presenter, but I put a lot of effort to make magic live. Unfortunately, I don't have any backup plan, so I need to trust in my skills that everything is working. And this session, mostly I talk about software delivery, how we do it. The DevOps also covers troubleshooting, the different kind of self-service capabilities for the developers. But today I want to talk about how we deliver code from development environment to live. And I do it in live. So And before I go deeply into that technical stuff, and I probably say there are nice pictures as well. So it's not only the code. So why we need DevOps processes? So if you see some statistics, we have like 150 developers producing code, and they are very efficient to write something. Sometimes it works, sometimes not. There is also an interesting slide about deployment statistics. But all these 100 developers, we rely actually 10 infrastructure guys who do actual system configuration. They provide servers. They are really hardcore battle engineers. And when we have something in the middle, automation engineers who know a little bit of infrastructure, will know a little bit of coding, and it's sort of fusion between the developers and infrastructure guys. So as automation engineers, we don't wrote any test. This is the duty of the developers. We just make sure that all those automation processes, that the tests are there, so are working. Also, we provide the visibility that what services are up and running, how deployments are working, and yes, most of all, there is a self-service for developers. Sorry, there is just so many guys who can write code, and every developer can deploy whenever they want. We don't have any release windows. We just can't do it. So we have provided framework how to deliver code. So a little bit about what we use. So our code is running in mostly in Rackspace, so we own a private cloud with dedicated hardware, which is not shared with anyone else, and some workloads are running in Amazon as well. And we do a lot of automation from infrastructure side as well. So the Terraform, is there anyone who doesn't know what Terraform is? So Terraform is automation framework to provide server resources. So if you want a virtual machine like in AWS or DigitalOcean, then HashiCorp have built a clever tool where you can just write a configuration file and we create the server for you. Then configuration management tool, Chef. Is there anyone who doesn't know what Chef is? All right, let's continue. And
every restaurant has a chef.
Yes, every restaurant has a chef, and pretty much yes, we are competing with the restaurants to who can configure our Linux servers. And also, so 2 years ago, we started to experiment Docker. We lived like quite a long time with open source Docker products. Now we are proud customers of Enterprise Edition. We are paying quite a lot of money, so we have to be proud of it. But actually, it's quite cool as well. Docker is very open, and to get the feedback. And as a normal Estonian, I whine a lot. So for Docker, they translate as a critical, constructive criticism. And sometimes they say that they do things better as well. Now, what else we have? So the New Relic. So New Relic is a quite expensive service where you can get the visibility, the performance. If you have a request, so you can measure the time where the time has been spent. And in our life, the database is the slowest component.
console. We use service discovery. So every service what we write is added to database called console. Console is like DNS server, but also on steroids. It has HTTP API. It has key values store. So if you use the DNS, when console is just a step further. Gray logging infrastructure, like Elk. I hope I don't have to talk about more. When also a lot of dashboards using Grafana, and Grafana gets its own data from Zabbix and Prometheus. And it's interesting that so Zabbix was here before, and we started to use Prometheus because we were really unhappy with the Zabbix dashboard, and we additionally we built a parallel so monitoring infrastructure. Now we have zoo of databases, so MySQL, Mongo, Couch, Redis, MC Router. I believe there is even Postgres somewhere, and Memcache as well. So and why? Because we have a lot of microservices and a lot of developers who are very creative, and we don't tell that MySQL was here first, so stick to it. No, we are open any kind of solution as long as it serves a purpose. And as you see, in the front end, we have like 150 already containerized services. I checked this morning or evening, and today we use Node.js, PHP, Golang, Python, at least in microservices. Also, there is some little Java as well, because we use Jenkins a lot.
So that wrapping up, you had like around 150 engineers working on the code base and equal amount of services, so does it mean that everyone can have one?
Yes, everyone can have at least one.
How do you measure the performance between the services like Zipkin or something? Because this is not the whole tool set, right? Zipkin or
Okay, so performance monitoring is what we do in New Relic.
Between services, right?
Yes. Yes.
Okay.
All right.
And how much you pay? You actually install on every app node New Relic agent?
Yes, we do.
And they charge like $120 for a single one?
I think monthly it's more than $20,000. I think. I may be lying, but it's you see it's the size.
2 bitcoins, I thought. 2 bitcoins.
So yes, there is always talks that maybe we should use something else beside New Relic, but we have so much work to do that we better pay, as long as we have investors' money to burn. We will see what we have next year. Anyway, now this was running in our data center, and I want to talk about little transformation in development environment as well. So in the beginning, we had a VirtualBox running Ubuntu server and Vagrant automation, which also triggered Chef. And it was really slow, and I hated it a lot. It was so bad that people who really understood, like infra guys who built it, they said that you have to provision it like once a week when you don't have any problems. But because I am not a developer, well, at least I provisioned once a month every time I had problems. So when 2 years ago we started Dockerization experiments, at least we didn't run anything, but so we had truly experimentation. So one criteria was that we don't use any Chef, because Chef is great for static server management, but not for dynamic development environments, at least in our experience. And luckily, this is so fast that now I have a first demo to show how it works. see. I'm gonna smooth.
Wait, why is Chef back for local? Like, what were the downsides?
So the thing is that Chef has, at least the way how we used, so we used the central Chef server, which had owned the database of existing servers. But sometimes you wanted to start it from scratch, and you deleted your VM, and you were immediately out of sync with the Chef database. You had to remove your instance from the database and start all over again. Plus, our environment contained all configuration what you needed normally in data center, not in one server, and running through all configuration recipes just took their own time. So what is different when compared to Dockerized environment, that all components, I will show a slide later, have been pre-built. So what is happening? We just pull the Docker images, start it up, and we have very little configuration what we do. So yes, actually it's the slowest provisioning what I have so far. One minute. To get up and running, and I hope it's running, because the next demo depends on it. So this is not that slide. Oh, I know. So thumbs up, fingers crossed. Okay, looks good, looks good, looks good. There is a very big lag, I can see. All right, so at least. No, this is actually running in my own computer except database. Database in my Pipedrive office. I can run database locally as well, but I haven't set it up. So what happened during this 1 minute? So as I said, we pulled a lot of pre-built images. So if you remember, I mentioned console. We have a console server running. Also one service which actually, if you create the container, registers container as a service in console. There is no direct integration between console and the Docker, so we use additional helper which just listens events in Docker stream and creates payloads to console. The console API is very, very simple, RESTful, so anyone can do it. So, of course, Nginx to provide SSL determination, when internal API gateway, which does authorization and rate limiting, and most important, routing to microservices. And yes, if the picture what you saw, so we had our own front-end service, the back-end service, some default ones. If you really want to have Pipedrive running, has to be present. Now let's start coding and the daily work what the developers do. So provisioning development environment, I guess it's not a part of the daily work, but sometimes if something is broken or you need some new features. Let's go. So I prepared a small pet project. I started yesterday evening, but I had very productive using internal frameworks. And in what we, let's see, can I do this bigger? So I have Node.js project, and it provides some API and very simple front end as well. And usually how a life works is, So what we have to do, git checkout when install the libraries. So npm install if you know Node.js, or if you're PHP lover, you use Composer, Golang. I hope you all use Dep or something else. Golang is also very interesting choice. So I have all Node modules already installed. I'm not gonna waste time. So the next thing what developers just do in any service what we have, we use Docker Compose utility. We start Docker Compose up. So obviously this is starts running in development mode. So we have some Node mon executing. All right, it looks we are all cool. Some health checks are happening in the backend. And let's see, I have prepared. So last date you can see there was a status code 500. So let's see if I get something else. Yay! It's working now. Let's see what my task is to debug why this button doesn't work. It looks that we have two buttons, and the second button doesn't provide any free money, but at least it tells something about the environment where it's running. So it's a local development and container ID. Let's take, and if I go to live, I prepared everything. Let's go to, so I hope I haven't created some backdoor because I am not I am not a developer, but I'm gonna take it down later. So the same service is running in live environment as well. Very simple. This button does nothing here. We just get container information. So we have running in Chicago data center. This is the container ID and some component version. Okay, let's get it fixed. So to make our product managers happy, so take it away this button, what it does not provide any value. Wait, this is, here it is. If you want to see, this is actually,
This is how you fix
we first create problems and then we fix them. That's everyone that works in IT, right? So small. So you just wanted to point out. So the actual service is running independently as own port. What is happening here? So API gateway routes the request to the right service. Just a small detail. All right. So I'm really positive. Is anyone Pipedrive here? No. Because I need Pipe process. Let's see. Because I need to talk about the process. But first I'm gonna commit the code. Otherwise. Yeah. All right. So. Now, before I'm gonna demonstrate what happens, first I'm gonna take some time. It's gonna go very fast, and I can't explain in the middle. So I'm going to GitHub to that branch, and I add a label ready for deploy. As this label triggers all the automation magic or automation hell, depending what is the result. So we have an in-house developed automation tool called Racket. We have quite a lot of tools because in history we still have the two CI system, but we are getting rid of one of those as we have so many Dockerized services. So what Rocket mostly does, it checks that tests are passed, merges existing or latest master to that branch, and triggers Jenkins CI/CD the process. So obviously we build the project. When we start testing, if tests fail, obviously we cancel deployment. When we actually execute a functional test framework, so we create mocked services depending on the project, what dependencies it has, and run functional test suite. So if tests fail, sorry, no deployment. So finally, if that has been passed, we are going to deploy to staging. Also, if we don't want to go to staging, we have quite a lot of sandboxes where we can deploy manually and try it out. But if we do automated deployment, then let's pretend I test it out in the sandbox area first. And I'm ready to go to staging environment. So we upload image to Docker Hub, so our favorite Docker image repository. When now after that step, we going to do the actual deployment. So we use the Docker Swarm, the latest Swarm mode. And actually today we migrated the last service from the legacy Swarm. Yes, I can tell that we have only one cluster left. And we do Docker stack deployment. Before we used Docker Compose, and it was very funny to hear when Solomon Hykes from CTO of the Docker said that Docker Compose was never meant to use in production, and for us it was like a critical component. Then, if we have deployed to staging, we run actual integration test. During the deployment, we have one safeguard in place. In case if a container does not start, so unit test passed, the functional test passed, but there is still the issue, then actually we break the deployment here. So we might have 2 different versions at the time, or not, depends when the deployment process triggered the halt. So integration tests, and if we go to live, we run smoke tests. And eventually we collect the statistics and report what happened. And assuming so, I said that first we go staging, then we go to US live, so it's primary. It's also configurable, and because we have we have 3 data centers, depending on what kind of service it is. Normally we have services for customers and also internal tooling. And the last step, if a Jenkins has finished, we start the synchronization. We deploy the same component to sandboxes and the test environment, depending again configuration. So I'm going to do a demonstration, and on that window you will see the Jenkins jobs. What are triggered when this is the Rocket which initializes, it listens GitHub events and starts the deployment process. And here we have another dashboard where we just see the status of our deployment. So here I filtered out in purpose to show you like Chicago and Europe data centers. So everyone with me? Any questions? Because if I start the process, I can't talk much, just show and hope. Yes?
So you first roll out to production and only then to test environments?
No, first staging, then live environments, and then because we want that sandbox environments are also in sync, if we want. We don't have to do it, but for a demonstration purpose, I want it. So when we synchronize the latest code to sandboxes as well. So if developers are working in their sandboxes with daily life, then we should be up to date. Yes.
The pointer, the green button.
Wow.
Question about the Jenkins. Did you use GitLab?
No.
Did you try now?
No, we don't have GitLab.
Why?
We use GitHub.
On-premise?
No, we use SaaS GitHub because we are a SaaS company. So we also have an image that we trust other SaaS. And it's also an interesting story that every time if GitHub is down, when there is a discussion that we should in-source the Git service, like use the GitLab, and I'm guys, if you make a mistake and Pipedrive is down, should we tell our customers use Salesforce? You can run it in-house and be totally responsible for it. So yes, everyone can have a bad day. So for us, I will say that we have so much work to do to outsource some responsibility for conveniences is worth it. So I'm gonna create the pull request. I asked if somebody from Pipedrive is here because somebody has to do a pull review, but no, I'm gonna ignore process. So
What could possibly go wrong?
So you saw the change. It was very simple.
Can you have multiple ready for deploy later, say in one repository?
Well, yes, we can, but I'm gonna start it and talk later. So let's see. So you can see now there is one item added to a queue. This is some other project. So, there is also some lag when it starts blinking and stop blinking. Now you can see that it starts triggering Jenkins, and I hope that we should see something here. Maybe I need to do refresh.
Have something.
Yes, all right.
Meanwhile, there was a question.
Yes.
Continuous integration in GitHub. So jobs are started if somebody sends pull request, yeah?
So the pull request means that somebody has to do a review, so it means that it's ready for deployment and merging to master. So yes.
I mean, if I fork your repository and send pull request, these jobs will be started. And if somebody else and else again and again do it, it will be started on your infrastructure, yeah?
So you mean if somebody else does it same time? So
Doesn't matter the same time or no.
so you mean like parallelly?
They are private repositories.
Yeah, you cannot really fork the repository.
It's about private repositories, but you have also open repositories.
Yes, we have some open source stuff, but okay.
But do you build it the same way, like the open source stuff?
Not really. We use external tool CodeShip to run the test suites for open source stuff.
Problem that's somebody decided to brute force the infrastructure to those just pushing plenty of pull requests and it's plenty of jobs in the infrastructure.
So
Again, it's a private repository. If some developer does it, fire.
Well,
if it's more the same for open repositories, for public repositories.
But Jenkins will not start to build it like in parallel. There will be just a queue of jobs,
but
depending on how much
workers.
workers.
Will be working on some trash jobs, but normal jobs will be blocked.
Yeah.
All right,
You can remove some pending jobs from Jenkins.
All right. So some comments. So in Pipedrive, we don't use a lot of open source stuff. We have some repositories, but I would say at the moment it's we really have pull requests from external developers. So I know only once. Mostly we do open source and we deliver ourselves. Also, we have, so regarding parallel deployment, so if we go to live, when the policy is that everything should go through Racket, so Racket does the queuing. Also, if we do deployment to sandboxes, when Jenkins has pipelines, has own ruling in place, so same time if there is a deployment to live, we can actually do deployment to sandbox as well in parallel thread. So what is currently where we have happened, now we are executed integration the test suite, maybe. No, we are doing live deploy, yay. Sorry, I can't see the font, so probably you see only colors.
I see something blinking.
Yes. So live, it's the live deployment. Another comment what I didn't mention is that so if we build the Docker image for staging, when we have tested successfully, when we trust this image, we deploy, we use the same image in every other environment. So otherwise, there is a very high chance that if we rebuild it again, that the result is not identical, because we rely on external sources, especially several times we have sorry. Several times we have got some corrupted libraries from NPM, even if we rebuild the same source code. And before the Docker, it was really bad to recover from it. We went to some staging environment and literally copied the file because we thought that they are working. So at least if that same similar situation happens again, when every build has own unique tag, we know when to go back. So live deployments is still happening, and this is only still running in US.
What does it do? Like makes a build of from source, like does npm install, then switch the symlink switch, attaches a mounted folders, database migration?
No, all the code is copied to a Docker image. So we build for staging all the assets, the fetch translations, npm installation. So this is happens before we can deploy the stage. And then we copy everything into the Docker image and hope everything works. And that's why we start testing. We have 3 levels of the testing suites, plus the auto stop during the Docker deployment.
They don't do database migration during deployment. They have a dedicated team for that.
Yes, the database is very interesting topic. We have very different solutions for that. As I said, that. For the biggest database, we have infrastructure guys take care of it, and but there are some small services where developers take care of themselves. Now, what happened? Racket finished its job. I expect that we should see. I'm gonna do a refresh here. So we see.
JavaScript. It's live. So it's a blue-green deployment?
No, we do mostly in-place switch.
Okay.
So the testing happens in staging, and if we need some, let's say, the A/B testing, when we deploy different version parallelly, But at the moment we don't do blue-green, but we deliver entire stack and switch the load balancer.
How do you do rollback?
We have a previous Docker image. We just execute the deployment and replace all the containers. And if we do the rollback, when I don't know if you notice, but you can see that it's because on the big screen it's very bad to see. So the pipeline itself is unified for all steps, but if you see those numbers, well, dependency installation where we run as npm installation, it doesn't take 7 milliseconds. It takes at least a minute, and we have caching in place. Everything is optimized for speed, delivery, and security. So we pay more for storage, we pay more for CPU. You don't have infrastructure to run tests is I think 3-4 times bigger than the actual staging environment. So yes, the speed of delivery is not cheap. All right, at least some real numbers as well. But took some environments deployment took 50 seconds. Here, why it took 2 minutes? In G Live, I got at least 3 instances, so it took more time. There is some graceful shutdowns, so we don't kill it. We wait until container finishes all requests and so, or any other customers, and then we switch it off and replace it. So questions, comments?
Most of the time is on this step is pulling the image, basically.
Yes, it is. Pulling the image plus the actual replacement as well. Some services have like some 30 or more instances, so we even where we need to use some parallel threads, and it can take several minutes. Right. But yes.
Do you create a new container for every new request, right, to run the tests? So if more or less at the same time 3 commits are done and approved, you create 3 environments.
So depends on which test suite you are talking about. So unit test, we run it in one container because we are so fast. For functional test, we provision an environment, and mostly there is the functional test suite is quite small. It's service specific. It's also one container which executes the test suite. The integration test suite, depending on the service, I can even maybe. So, for example, the legacy applications, it don't follow the microservices. So you can see that the entire deployment here took like 20 seconds or near to 30 minutes. So and for us as an automation tool, it's like we are thinking how to optimize, because for the staging environment for us is criticality class 1 service, and if production is fine, then for infrastructure guys it's criticality class 1 service as well, because if we can't deliver the code, even if we do readme chains, we follow the same process, we are going to have huge queues because we can't allow untested code to go production. The developers are unhappy, the product manager are unhappy, and so it's also doing this. I say it's fun to do, but it's also quite expensive, and you need to treat it as a live environment. In fact, all our tooling is using same auto healing and recovery mechanism as an environment as live services. Now, I have a few slides as well left. All right, so how we live. So today we have like live staging regions, 3+3. So we are all, it means that both environments have synchronized the databases. Roughly 15 sandboxes. Every team has their own sandbox environment. So today I checked 154 Dockerized services. So last year we did executed 71,000 deployment and test jobs. I don't understand, but we collect everything in our database. It's very interesting that quite a lot of them were successful. So it means that successful to sandbox, to the test, staging, to live. So 61,000, I guess, so 80% or something was successful. So successful ratio. But I don't really feel it because we have our own on-call people who are responsible if test suites are failing, if deployments are failing, then we need to investigate what is happening immediately. And for me, every time if I'm on call, I am feeling that it's hell is open. Everything is failing for me, but same next week everything is all green. But anyway, maybe it's karma. And eventually, successful deployments to live 15,000. So all the rest, it means we did delivery to staging or the test environments.
From the same numbers, you can also tell that every 3 times you ship to production, you fail 2 deployments because 15,000 deployments to production are successful, and overall 71,000 minus 61,000 successful is 10,000 failed deployments.
No, it doesn't. No, it doesn't mean that. We also count manual deployments to sandboxes which are not delivered. So. Yes, I see your logic, but I didn't count it out how many were started to staging and they didn't pass. So yes, it's interesting number to compare. I will look.
That number wouldn't fit here probably.
Why not? Well, anyway.
With a smaller font.
So what do you think you see here? Oh yes. Any other opinions?
Maybe the timeline of deployments per day during the day.
Yes, it is reflecting it here as well. I will talk about more later, but it's not deployment timelines. Any other ideas?
Lines of code added, lines of code deleted.
No, not at all. What? Developer time?
It's Jenkins being busy.
No.
So is it lowered to some different services?
Yes, it belongs different services. So every line is different.
The red one is very high.
No, not load, but so we are getting close to it. So it's related to services.
Service uptime, availability?
Yes, uptime availability. So mainly availability. So every red mark means that something failed. And if you have so many components, you are really distributed. Something is failing all the time. Unfortunately, we have 150 developers, but we are not so brilliant to provide fault-tolerant code. So we have to adopt, and sometimes it's not only the code which is faulting; it's also infrastructure. So yes, you as the engineers, if you have stable environment, you are very lucky. But if you start to grow and go more and more, it means there is very high chance that something is failing. So let me tell about something about. So this is the chart about service discovery. So we use console exporter to send metrics to Prometheus. So every red is failure, green is okay. So gray area means that the service did not exist at that time. And the easy thing to interpret, so if service did not exist and starts with red and goes green, probably this was high probability deployment event. But if it was green and suddenly red, this is some failure happened. And all consumers, all components which talk with each other, we have to understand. And it's very hard to understand actually. As purple. Purple means that this service has several instances on that particular host. Mostly we have distributed that all containers, even if my service has 3 containers, they are running on different hosts. So here we see some overlapping that this service has few containers. So it means that if there was a failure on that host, we should take a look. But yes.
What does it mean that it didn't exist, then failed, and then continued not existing?
So, you mean?
Yes, the gray, red, and then gray.
Yeah, in the middle, in the very middle.
So, like here.
Yeah, like here.
Yeah, or even here, because this was like this all the way.
Mm-hmm.
You never went green, actually.
So probably I would, well, because I don't have any service names and any context, but from my experience it means that there was some kind either deployment or probably deployment. That the service started, but health check never went to green and failed. So
someone tried to fix that? He failed and he gave up.
No, here it didn't came up on that line, but probably there was another deployment. When I took this picture, this is like 12 hours of spanning. It's not like happened in 5 minutes.
What happened in the very beginning, there was these 2 gray rows from the top to the bottom. Yes.
I think maybe there was a timeout. I don't have any explanation. No, I think that we lost some metrics at that time. So it's interesting picture. So you think? So how did you like? You think it's looks all nice and shiny? So we have so many problems still to fix. So we don't have any automated rollbacks. So if you have problems, well, we currently discover manually, and well, we have alerting in place. But when we go and investigate ourselves, and developers they then deploy the previous thing. So this year we're gonna build automated rollbacks. Also, CI/CD process is stable and fast. It's war. It's never-ending war, I must say. And one thing, what helps actually breaking components smaller. The tendency in Pipedrive is that everyone starts with microservice, and in the first months it's really micro, and one year later it's monolith again. And then there is another plan that, okay, we need to split it to smaller components, let's do. And I guess it's fine. So we are continuously evolving. So again, visibility is the key. If you have so many components and if you are failing, you need to understand. So 1 year ago, we didn't have dashboards, what I showed you. So we implemented quite a lot. I would like to open source those projects, but they are a little bit very specific to Pipedrive framework. You need like console and RabbitMQ. Setting it up is quite a hassle. And also user experience. First year when I started, everyone was complaining there is no documentation. All right, Confluence is full of documentation. Now we are complaining. Well, good interface doesn't need documentation, so user experience is also key thing what this year we are going to change. At least Jenkins part will be refactored a lot. And of course, my team is also hiring, and we don't pay bitcoins. Sorry about it. So more questions, and you can tweet.
Let's start from there. So what about DevOps? You didn't talk about DevOps.
So which aspect? I talked about continuous delivery.
That, you have no ops and devs, you have combined team. You get at night.
So we have shared, we have very clear responsibility that developers, they deploy their containers, they troubleshoot, and in fact, I'm doing onboarding myself. And for example, if they have a problem additionally, they can go to, let's say, to our Docker management system, and when, for example, if I think that my container has a problem, I'm gonna, it's very slow here. So let's say it was Renno. All right, so 3 containers are running. So our developers, when they can come here and troubleshoot themselves. So the container gives very good flexibility how we maintain. So operating system is the responsibility of infrastructure guys. So we provide hardware. Well, of course, it's outsourced. We provide server configuration so that our Ubuntu servers have secure configuration and everything. So all containers. So if you build it, you deploy it yourself. You have the tools to figure out why your service is not working. If you need to restart it, you come here, restart yourself. We don't call ops that your container is not working.
Does it mean that the developer is responsible for that? Well, actually, also
Yes, they are. As I said, 150 developers, 10 infrastructure guys, 10 automation node. We can't follow anymore what they are writing. Before, in the first year, I was involved a lot every Dockerization project. Now we have best practices in place. We have certain patterns how we build and deliver. Now I can't. Now I don't even understand what they are doing. Before it was simple. Oh, well, I know those guys. They have this problem, yes. So if you build it, you ship it. You are responsible for uptime. You have to figure out how to do them. Monitoring. Every service has own specifics how to do monitoring. We have, as you saw, we have a zoo of different components. So infra and automation is just to assist to provide with self-service and visibility and automation.
Like question, just to continue this topic, sorry. So it means also on-call duty for developers, right? 24/7.
Yes, and it's also another funny story. But at the beginning, when
not for them.
but the thing is that if we give them on-call duty, then you can't throw a buggy code to live. So even if you have some hard deadlines, so you may start think about it. But if you write the code, that is it wise enough to deploy in Friday evening, and maybe you have to fix it over the weekend. Or at least somebody in your team has to fix it. So you have some sense of responsibility. And what I said, it was funny, was it wasn't so at the beginning. So when this duty was delegated to developers, we several times we missed some calls. And first year, some services, like microservices, were down a couple of hours. But now it has been improved. We have like escalation policies in place and so etc. So yes, it's not a big problem if you follow the processes, you test your code, automation safeguards will take in place, but of course the true testing happens in live.
Yeah, I have a question.
Yes.
Have you considered using Kubernetes instead of Docker stuff? Because Kubernetes is like standard today.
It's a very good question. When we started experimenting 2 years ago, well, more than 2 years ago, let's say 3 years ago, when the first thing what you heard about Docker, it's for development environments only and maybe for testing, and you shouldn't go to live, and especially don't run databases in containers. It's so immature. And while we were living in that world, so we had very narrow option like legacy swarm nowadays. So first Kubernetes, the Mesosphere was very popular. Also some Nomad, if you haven't heard about it. When Swarm versus Kubernetes, there wasn't much differences at that time, at least 3 years ago. It was just the orchestration, and orchestration means that you have a bunch of Docker hosts, and you want to deploy a new container. Orchestrator says, here is the best candidate to serve your workload. Later, we got a lot of different features, and why we went to Swarm was that. Swarm had very good integration with the console, and it worked in our OpenStack infrastructure quite well.
But well, like auto-scaling, you can have...
Auto-scaling, there was no such thing. There was no security management or...
When down, Google Cloud and Kubernetes.
Yes, but those are quite recent developments. So when we started, now we are quite stuck because with 150 services, it's going to be a challenge just to change the practice because everyone else is using Kubernetes. So we invested quite a lot of time to make it working. And maybe if I should choose it today, probably Kubernetes would be first thing to try it out. But 3 years ago, I tried Kubernetes in AdGas actually, and because it was beta and every release had like breaking changes, I was not very happy with it. But yes, I don't say Kubernetes is bad. It's excellent orchestrator, and if you start from scratch, you may look into it. But I don't say that. I only miss one thing from Kubernetes. It's pods, where you can tell that 2 containers can run on same host with Swarm. It's very hard to make it similar thing.
You mentioned you have lots of developers and lots of microservices and probably lots of new microservices. Who's in charge that non-functional requirements are met, like everything that needs to be logged is logged, business metrics are in Grafana, stuff like that?
So why do you think business metrics are in Grafana? Well,
somewhere.
Well, in our environment, the teams are autonomous. And in fact, we are so autonomous that I can't do escalation, that both teams are slacking, and I can't meet my goals because we are not doing some simple things, what I need to deliver my objectives. So that every team is independent to choose own priorities. Usually, at least business objectives are more prioritized, but everything else is negotiable. So when I did legacy Swarm migration to new data enterprise edition, Docker Enterprise Edition, I had to negotiate, I had to bribe, I had to motivate, I had to escalate, and yeah.
So essentially, you're in charge that
Well, yes, for example, Docker is my baby, so this is my fetish. I don't ignore it. So if I want that every team are following best practices, when this is like, I feel my responsibility to deliver both non-functional requirements.
You said that developers own their services. It's excellent. And I assume that's why you managed to have a lot of different DB systems, right? Like MySQL, Postgres, some other ones, because developers decide which DB to put into their own service, and then they own it, right?
Okay,
No. But
Okay.
I wanted to hear that. So how do you make that happen? Because usually in companies, it's like there are some DB experts, and then they say, okay, you guys, everybody uses Postgres, and everybody just goes with that, or something else.
Yes,
how do you
so the developers own services what they write.
And data sources.
And data sources are managed by infra because
because it's tough, right?
yes, the trust issue. The infrastructure engineers have best practice how to do backups, how to do recovery. It's not complicated to set up single database environment, but if you have to maintain a cluster, keep the data in sync and consistent, you need expertise for it. And the developer's daily job is to write code, like I just demonstrated.
And if the infrastructure engineers have been doing with one database, and then some engineer wants to use another one in that microservice, should he bribe the infrastructure guy?
Pretty much, yes. That's what I also do if I want like a new upgrade for of the Docker engine. So I'm not managing Docker hosts, and I'm lucky that the education of how to use new services is also quite complicated topic. But I delegated this responsibility to maintain Docker host to infrastructure guys because they do it the daily basis. But so what I did, I told my requirements and I teach them how I see it's the best fit to run the Docker. So developers, they can do the same thing. They can give input how to manage the database. So more questions?
Maybe you can bring some examples of disasters related to Docker.
Related to Docker. So there is I have slides in SlideShare where I mentioned several disasters, and we did most of the time we did it ourselves and with unoptimized configuration. And I kill this killer container issue. That we deployed the service which managed to break the operating system. Because we had the auto healing, we did it every time it crashed the host. And eventually we had only one host left. And the reason why this host didn't crash was that all resources were reserved. It just didn't fit into it. So it was my most interesting disaster in the Dockerization world in my career.
What was wrong with this container?
So container was actually, it was quite fine. It just needed to serve quite a lot of requests, and we had some kernel configuration issues what we later fixed. So we added some additional fine tuning. We upgraded Linux kernel, so also be up to date is good thing. Solved lot of things. So
the distro versions are different. Like you can have Debian, CentOS, or try to keep it
well, at least today we have Ubuntu and Debian, and I hope we don't have to do any Red Hat family or. But yes, I don't know why we have Ubuntu and Debian together. So.
What about like okay, if developer needs to to test all these microservices all together, he needs to get them up on his machine, so his machine must be really powerful, right?
No, the thing is that with development environment, at least the background machine requirement was 4 gigabytes of memory to run all services. But now we can manage with 2 gigabyte virtual machine, so we use Docker for Mac. If you have heard that Docker runs natively in a Mac, it's a big lie. It's just another virtualization hypervisor. But we have mandatory services, and if you start working, you start up your services what you need during that development. You don't run entire suite of 150 microservices.
But sometimes when you need a really powerful computer.
Not at the moment. At least we have managed to decouple microservices that you don't need everything running. And microservice itself is, at least when we start, we only need less than 100 megabytes of memory and 0.1 CPU or something like that. In fact, we have like only the 10 Docker hosts in one cluster, and I can't tell the number, but we just run like 300 containers in one, something like that in one cluster. So it means that all services we have duplicated instances. But yes, if you want to run everything, then we need probably we shall go out of our local environment and produce development environment in data center.
But during the tests, you're checking all these services, right? So you like
only dependent services for functional tests. Yes, it doesn't make sense because provisioning containers is fast, but if you are already counting minutes and seconds when and you see that creating a new container takes like 1 second, you feel that this is already wasted time, and boot up of a service takes also another maybe 3-5 seconds. So to make atomic changes as frequent, as fast as possible, we don't provision everything. It's going to be very slow, and if we want to make it fast, it's even very expensive. And staging environment, it's constantly up. We don't shut it down, except the ones which are in AWS.
That was it. Thank you, Renno, so much. A last small announcement. We also have a YouTube channel. If you, the other time, if you can't make it to the meetup, or you want to watch over one of the talks, you can conveniently find them there, and yeah, take advantage of it. See you in February. Have a good one, and yeah, see you in a month.